Hi everyone, so let's solve this problem. So a few remarks that I mentioned in the previous videos, but it's good to mention it now as well. Any integers can be written as products of primes. So in particular, we can write that product as increasing prime, and then we get distinct primes, and we can just collapse things and collect the similar primes together, and then we can write an integer as product of primes, each individual prime raised to some power. So in particular, we can write any integer of the form a and b like that. So assume first that a divides b. Then what this means is that there exists a k inside of z such that b is a times k, but we have a specific form for a and b. That form is b is p1 s1 pk sk, and that is equal to P1R1 PK SK multiplied by an integer k. But since we are dealing like with prime factorization, we'll do one extra step and use it. So here we can write also k as products of primes. So P1 R1 to PK, this should be RK. So then PK is also product of primes. Let's call it L1. Q or let's use U. QU to the power of U. But since all the primes are distinct, we must have that k is of the form. We must have that k is of the form p. So all the factors of k must be of the form pi raised to some power. So that means just because they must equate to, once you multiply a by k, they must equate to b. So then this would be PR1 multiplied by PK SK, and you have P1, let's call it L1, up to PK LK. So here, since A is less than B, absolute value of B, because A divides B, we must have that those P1 R1 all the way to PK SK, this is less than or equal to P1 R1 up to PK SK. So another way we could write B is that we could write B as, so this first, so this we could write P1, so R1, this is S1 to sk. So then we have that s1 minus r1 pk of sk minus rk is bigger than 1. So then we could write also b as p1 r1 all the way to pkr. This is rk. Yes. So then this would be here p1 to pk, and that would be multiplied by p1 s1 minus r1 up to pk of sk minus rk. So we can write b also like that as well. So that means by the uniqueness of the prime factorization, so then we must have that k is equal to p1 s1 minus r1 times pk of sk minus rk. So we get k is equal to that. So that means that those one of the, so then we get the following. We get that p1, so we get that pi to ri is less than pi to si. So therefore we get that ri must be less than or equal to si. And we're done. At least with the forward part. The backward part is if ri is less than or equal to si, then you have that b can be written as p1 to r1 pk to rk multiplied by p1 to s1 minus r1 to pk of sk minus rk. So then you get that you have written a multiplied by k. So then you have that a divides b, and we're done. All right. Thank you, everyone, and I hope you enjoyed the video, and I will see you in the next one. See you.